Alright, y'all, we are back with part number 2 of trying to repair this Tektronix SG503, which is having some display issues and probably some power supply issues. Or something is loading down the power supply. Um, so, in the last video, we did some work on this guy where we replaced a capacitor, cleaned up the frequency switch, and we did verify that, the unit works pretty well throughout the frequency range when hooked up to a scope. The amplitude switching seems to work, but there is no display. The 7-segment display doesn't. It just provides zeros. It does work somewhat in the sense that if the unit isn't leveled, it flashes zeros, which is what it's supposed to do, but that's it. So towards the end of the video, we figured it'd be a good idea to look at the power rails, and we found that both rails, the negative 22 volt rail and the positive 5.2 volt rail, were low, very low. And we are running this guy from a TM5000 series mainframe, not the 500. Now, I've read in multiple sources that 500 series plugins are compatible with the 5000 series mainframe. And so I did reach out to TechScopes, which is a group that I'm in, and they said the same, that people have personally used an SG503 in a 5000 mainframe and it works. So there's something else going on here. So we're looking at the voltages, and they are low. And so for the 5.2 volt rail, I think we measured like 4.7. For some of these ICs, like these CMOS counters, their data sheet has a minimum of 4.75 volts to run them, and the drivers for the 7-segment LEDs, the data sheet that I found for it didn't give a minimum, but says in VCC should be 5.25. So the reason it's not working, showing us anything on the display, could likely just be to the low 5.2 volt rail. Now, I did do a little bit of tracing of that rail, and we'll start that soon. Just wanted to give a little bit of an overview, because it seems that the issue is somewhere on the plugin. So hopefully that's what the aim of this video is to find out where. So let's get started. Okay, so I had already done some tracing the some voltages from the mainframe, which is outputting 8.2 volts. On the 500 it would be 11.5, and kind of trace that circuit using the schematic. Obviously the voltages are going to be different, but the voltage drops seem to match up until I got here. So this is the first discrepancy, and this is a bit odd. So right now I am probing on this 2 amp fuse, and on one end I get 4.9 volts. On the other, there we go, I get 4.7, and this is what we've been reading at the 5.2 volt test point. But why are we seeing a voltage drop across a fuse? That doesn't make any sense, right? It's at the same potential. So there's nothing wrong with that fuse. So we think we should take a look at the schematic and see what could be causing that. But I just wanted to share that with you guys. Alright, so this is the schematic. This is the fuse F6 F620. That's that 2 amp fuse. And so this is where we measured roughly 4.9 volts, and this is where we measured 4.7. So yeah, what could be causing that? Now, what I do see is a lot of tantalum capacitors in this, you know, that are kind of, I don't know if across is the right word, but they are in close proximity. And then at our voltage rails here, more of them. So these might be worth just replacing. I mean, they're tantalum caps. I know they are notorious for going bad. And I definitely have these values. It's only 5 of them, so I think I might just go ahead and replace them. You know, I just, instead of trying to narrow down which one could be causing a problem, if any of them are. But yeah, I think I'll just go ahead and do that and see if that changes anything. Okay, so we got our new caps in, and guess what? Not a single one of those was bad. I don't even mean low. They were all within spec. So yeah, but let's pop it back in and see what we get. And of course there's no difference. Still the same. Yep. See, that's why I'm not a fan of that shotgun method of just replacing caps, and especially I am not a fan of it as being used as a preventative maintenance practice, you know, because you just don't know how long these caps are going to last. There's no way to make a accurate estimate of how long they're going to last. I mean, these are from 1974, and they tested bang on. So I also can't tell you how many times I'm in these forums where a post will start with, I was recapping my I was recapping my oscilloscope, function generator, you name it, and ... happened. It doesn't power on now. You know, so it just opens up the door for additional errors to be made. I don't understand it. There are people that will take equipment that is working perfectly fine and decide to open it and recap it. It makes no sense to me. Unless you find capacitors that are bad, okay, yeah, replace them. But recapping the whole thing, I'm talking about every single capacitor. There are people that do this. It makes no sense. So, yeah. Well, back to the drawing board. Let's take a look at the schematic again. Okay, so I have looked at this entire area of the circuit pretty thoroughly. You know, again, I was looking at that fuse and how there could be that voltage drop across that fuse. You know, we've replaced all those electrolytic caps. Also, this one I forgot, C640. I did end up replacing that one too, and again, it measured completely fine. This SCR I checked is fine. This Zener diode, I put that on the curve tracer. That's fine. This 6.2 volt Zener diode, Zener, that's fine. R615, R616, those look fine. This U741 op amp seems to be fine. Yeah, again, factoring in that the difference in the voltage, you know, instead of negative 22, it's negative 20 roughly. Yeah, all those voltages check out. So, yeah, I'm not. After all of that, now it seems to me that it's possible that it must be something elsewhere that's loading down this the rail. Now there are more capacitors. I'm not sure if these are tantalum caps or not. I mean, it could even be a bad IC. There's a lot of stuff on the um, 5.2 volt rail, so yeah. But it might be a good idea to start looking elsewhere just to see what else could be causing this, because I'm not really sure at this point. Well, I decided to just inject about 5.2 volts into the unit just to see if that would fix the problem. And so we got about 5.1 volts, and that's okay per the service manual. It can be between that test point can be between 5 and 5.4. So that's fine. But it hasn't fixed our display problems. It's no different. So before diving into the display and kind of potentially going down another rabbit hole, I just wanted to take a look at the representative waveforms just to see what we get. And so this is what I'm probing now, which is the first one, and you see, okay, the test point is on the attenuator board right there where that one is. So it's part of the output buffer amplifier. And sure enough, I'll go back real quick to so you guys can see this is what we should be getting. It does provide some conditions that you need to set the unit to, so they're right here. I made sure to do that. And that's exactly what we're getting, which is great. Alright, so I think I'm just going to move through each of these, and we'll see where things deviate if they do. Okay, everything's looking good so far, and I believe even this one is as well, but, you know, this is what we have to go off here. I mean, it's, you know, it's not very poor quality, but this is what I have on the scope, and it's a very interesting waveform. I don't, you know, if you zoom in a bit, or, yeah, very cool. But yeah, I think that's what they're getting at here. One more to go, but just one thing I did want to point out is for this one, they have 500 milliseconds. I believe that should be 500 nanoseconds. I get that if I said it's a 500 nanoseconds, so there might be a mistake there, but let's move on to number 6. Okay, this is the last one that they provide us. This is number 6. And if we look, we are looking good. So, all of them check out, which could be good or bad. Okay, so I've decided to stop dicking around here, and I started following along the theory of operation and probing through the circuit to see if we can hone in on this issue, this display issue. So I started right here, and so my unit is a serial number below B059999, and I just started doing all these tests, like for example checking to see that the outputs of R3058 and R362 are symmetrical, and continuing to go through here. Okay, and everything is looking good. All the tests that measurements that I've made match up with what is mentioned in the theory of operation. And until I get right about here, right where it says refer to figure 1 for waveform time relationships, and we're going to look at that in a second, but that's actually not what I'm talking about. So it says if leveling circuitry is operating properly, a high level is set on pins 6 and 7 of U490. So actually it's actually low on both these pins, I think. Which could be problematic because it mentions down here when they are low, the result is blinking front, the blinking zeros. So I've seen that before. It's not doing that. It hasn't done that lately, but it makes you think like this could all be due maybe to the leveling circuitry not operating correctly, or it could be something else. But I'm just kind of keeping that in the back of my mind, because although those pins are low, it says 6 and 7 are high, allowing it to count. Well, it's still U490 is still divides by 5 from pin 1 to 11 and by 2 for pins 14 to 12. So for example, the frequency division produces a signal with a 10 millisecond period at pin 11 and a 20 millisecond period at pin 12. Yeah, that's all correct. I still see that. But yeah, anyway, we're just gonna take a look at these timing relationships in a state generator circuit, and we're just gonna go through and see if all these match up. I've already got pin 14 U490 up. That's actually saved, and so that'll be our reference as we go through here. Yeah, and I think I might be able to get both this and my scope in the shot so you guys can follow along. But let's do that. See how we make out. Alright, let's give this a try here. I did dim the lights to hopefully so you guys can see the scope a little bit better, and of course it's still doing some funky things, so I apologize for that, but hopefully it cooperates with this. So now, as I mentioned, saved on the screen on the display already, that's this signal here, pin 14 of U490. So pin 12 is up top, so let's check that. Okay, and that looks good, and that's what I was referring to earlier. You can see the period is 20 milliseconds, so it is doing that dividing by 2. Alright, and then it's pin 4 of U432. Now I forget which one that is, so I've got to switch here. Alright, so that's pin 4 of U432. And yep, that looks about right. And then pin 9 of U432. Okay. So that looks good. Let's actually save this guy. Alright, so now we've got let's see. So now we've got pin 9 up there as well. And if I might take some of them off if it gets a little too jumbled up there, too hard to make it out. But yeah, actually, what I can do is, all right. So we are on. That was pin 9. Let's do pin 8. Alright, and so that's what you, there is that delayed pulse, that's good. So we are seeing that. And so then pin 12 on 438D should match up with pin 9 on U432C. So let's take a look there. U438D, gotta find out which one that is. Okay, so we aren't getting anything here. Unless I'm looking at this wrong. Yeah. Alright, so that's a problem. Yeah, I'm definitely probing it. So, yeah, I don't know. Alright, well, we'll notate that. This does not give, this does not match up. U438D. Alright. Next on to pin 8 of U490. There we go. Yeah. Pin 8 of U4. That looks good. Okay, now we'll do pin 8 of U475C. Okay, and that looks good. It might be difficult to see that, but it's kind of overlaying. It's exactly the same. And then finally, pin 4 of U425B, the auto range clock signal. Okay. Right. Okay, we're probing pin 4. Okay, so I did look through the remainder of the circuit description for the counters and the display, and it wasn't really all that helpful, at least to me, so I decided to go back to the schematic and see what I could find. And so one of the things I noticed is from this trace to U437, which is one of the counters that drives the, well, that connects to the display drivers, you see this, you see this trace here, from pin 11 to U440A. It says there's 4 volts. Well, I don't measure 4 volts. I don't measure really anything. It's pretty much close to 0. And so that got me looking around here, and that could be something to follow, but somehow I ended up over here, the range decoder circuitry, and I was looking at U450C, this quad NOR gate, and there should be 2.1 volts here. Well, I didn't measure 2.1 volts. I measured closer to, 0.19. So that got me looking, well, where does that 2.1 volts come from? And comes down here, connects to U475A, and also from the 5.2 volt supply. It gets brought down by this resistor, R480, which I measured. It is roughly 560 ohms. And yeah, so I decided to take a closer look at this NOR gate. And when I removed it from circuit, it did bring the voltage up. Not 2.1, but 2.9 volts. And I took a closer look at it. I've got it on this breadboard here. I'm testing it, and it's fine. So right now, everything is tied low on this one gate I was interested in, the one that we were looking at with pins 8, 9, and 10. 8 and 9 are the inputs, and so I've got them low, and the output should be high, and it is. So, and I, tested the other combinations as well. I tested all the gates on here, and they're all fine. So, and it's interesting because here they've got 3.9 volts, 3.9 volts, so that's the input that 8 and 9 connect to. So this would be low. But they've got 2.1 volts here, so I don't know. I don't know if that's an issue with the schematic. Maybe I'm missing something here. But yeah, because that goes directly to also another interesting thing. Pin 7. These are the 7-segment displays, so it's an important part of the schematic for driving these 7-segment LEDs. So I don't know. I'm gonna pop it back in and chase a few other spots on the circuit that don't match up, but I just wanted to point that out. Okay, so I was getting at my wit's end with this guy, and I pretty much came to the conclusion that if I wanted to fix this one, I was gonna have to really get a better understanding of the circuit and how it works. Now, mind you, I'm still learning electronics. I love repair because it allows me to learn more about electronics. I've never been formally taught, and I'm still learning as I go. And so my knowledge of how counters work was very limited. I understood what they do, but how they work, not so much. So I figured if I wanted to fix this, I was going to need to learn how they work. Okay, so we're looking at the schematic here, and you can see you've got these 4 cascading 7490s. Now, over here, so you've got U430, U435, U436, and then U437. Now, U435, U436, and U437, they're BCD outputs, or binary coded decimal. Those go on to the display drivers, the LED, the BCD to 7-segment display drivers. This one does not. The U430 does not, but it does. So, well, let me say, well, what do I mean by BCD? So let's take a look at the data sheet real quick for the 7490. Alright, so here it is here, and it also includes the 7492, the 7493, but we're only interested in the 7490 up here. Alright, so you can see these QA, QD, QB, and QC. Those are basically the outputs of 4 internal flip-flops, and they will output a signal that is flipping between 0, 1, 0, 1 based on at a pulse that rate or a rate or frequency that is based on the clock signal that is inputted into the chip at pin 14. And so you can see what that count sequence looks like right here. Alright, so here are those outputs, Q sub D, Q sub C, Q sub B, Q sub A, right up there. And then, so at count 0, you're going to have all lows. Count 1, these will be low, but Q sub A will be high, and so on and so forth. So that is the information that's coming out of these traces right here from each of the counters, the 7490s. All right. Now, there were a couple clues that I was given that I'm sure if you guys are, those of you watching who might be more experienced than I, probably knew right off the bat where the problem was, or at least had a better idea than I did. Because I didn't take advantage of these clues when I saw them because I didn't really understand this circuit. But anyway, we already looked at the representative waveforms that were given in the service manual. And here's one of them right here. Number 5. We know that all of the waveforms we measured were the same as in the service manual. So this trace goes all the way up here to pin 14 of this 7490, which is the clock input for this guy. Now, again, this isn't one of the ones that is part of the, it's a BCD output is not going on to the 7-segment LEDs, but it is part of this cascade of counters. And so one of the BCD outputs is pin 8 right here, goes through to this logic gate, and then is the clock for U435. The clock input for U435, which is that first counter in this, well, second, but it's the first one in the of the counters that goes on to the display drivers. So this should have been a clue here. We knew that this signal, our clock signal, was good, so that if these counters were good, they should have been passing on information to the display drivers, and we should have been getting numbers on the frequency on the LED display, but we weren't. So that was the trail I should have followed. And I did off camera earlier measure this pin 14, and there is a clock signal there, and we can do that now. So let's do that. Take a look there. Oops, sorry. Bear with me while I direct the camera to the scope. I apologize. I need a better rig for this, but that should do. And this isn't what. We'll probe the signal in a second, but all right, I'm going to do that now. This is pin 14. Okay. So that is the poorly triggered clock input to U435. All right, so that's there. So that's good. But let's take a look at another clue I was given. I had mentioned that, pan back over to the service manual, I was not seeing this plus 4 volts, okay, where it says U438D, this plus 4 volts, which goes on to this flip-flop U440A. I was not seeing this. Alright, that comes from pin 11. Again, this is another BCD output. on U437. There should have been some sort of BCD signal on that pin if all of this was working properly, and we had 0 volts. We can probe that now. Again, I apologize. So we can probe that guy now. That's pin 11 on U437. Pin 8, pin 9, pin 10, pin 11. Alright, that's pin 11. And we're getting nothing. Even when I adjust the, frequency, nothing. Change the setting, there's nothing there. Alright? So that's also a clue that something is wrong with this cascade of counters. Now again, each of them is connected. You've got the pin 11 from each of them is the clock for the next one. So that tells you something must be going wrong with this chain of counters. And I was looking at the first one, and you'll notice on the schematic there's no pin 13. Well, that's because pin 13 is a no connection. So it's not used. But I probed that pin, maybe even by accident, and I noticed I was getting a signal on that pin. And there should be nothing coming from a no connection pin. And that's usually an indication that maybe there could be something wrong with the chip. I mean, that's usually what I take that for when I see things like that. And I'll show you that right now. Let's find U435 again. It doesn't look like much, right? But let's zoom. There you go. So look at that. Yeah. That's on pin 13 of U435. So there's definitely something going wrong there. Now, if we probe each of the other ones, as an example, this is U4, sorry. That's U436. And that's U437. So it seems to me something must be wrong with U435. Now, I do have a 7490 in stock. Let's pop that in and see if it fixes the issue. Alright y'all, moment of truth. I popped in that U7490, a new one, and check that out. Yep. Now, again, that's just my, well, no, it is, because, yeah. Yep. So, yep. So that's at the 0.25 setting. 0.5. 1 megahertz. 2.5 megahertz. 5. 10. Now, see, this is the 10 that's been a little bit, scratchy or something. We know that's been having problems. So I think that's just a bad contact. But if we go to, there's 25, 50, and 100. All the way up to 250. Nice. So it's working. We've already checked at the the output, so we know that's good. So I am going to call this repair a success. I know there's still some things I got to do. Like I said, that knob needs to be tightened, and we got to figure out what's going on with the 10 megahertz setting. And then, of course, I'd like to calibrate it. But yeah, I mean, look at that. Another thing I'm curious though is the voltage, or the voltages, was that chip loading down the supply of voltage? I don't think it was. Again, I think that just the fact that we're powering this from a TM5000 kind of just put us on a bit. It put me down a bit of a rabbit hole. I spent way too much time on that, but yeah, in the end we got it though. So I am curious though. I think I'll check the power supply voltages real quick. Let's do that. Yep. So nope. That chip was not loading down the supply. I don't think anything is. I really think this is just the voltage running it through the TM5000, which is problematic because a lot of these ICs recommend a minimum of 4.75 volts. I mean, we're below that. So I really would be curious though if anybody who's watching this has one of these and powers it through a TM5000, if you could just let me know if you could just measure the 5-volt rail for me, see what you get. I'm really curious to know what somebody else measures, because I changed this. I didn't show this on camera, but prior to really, instead of just shotgunning parts, which I did end up replacing a lot more caps. Yeah, so you see those there, those were Tantalums. Some more over there. I mean, and it didn't do a damn thing. All those Tantalums were fine. I mean, they tested bang on with my LCR meter, and clearly they were working fine because it didn't make any difference. So, the only thing I could think of is that LM723 possibly, but no, I really don't think so. I really think, I know my TM5003 is good. So yeah, I think this might just be the way it is normally. So yeah, again, I'm just putting it out there. Anybody's got one of these and wants to measure those voltages and share it with me, I'd really appreciate it. But yeah, we're gonna call this one. Again, still got some things to do for it, but this video has been long enough. You guys have sat through enough of me just not taking. Yeah, I don't mean to waste anyone's time, but it was a really good learning experience for me, at least. Learned a lot about how calendars work, and that stuff will probably stick with me because, yeah. But yeah, I hope you guys enjoyed that. Again, I know I wasted some time chasing some tails that didn't lead anywhere, but found it in the end, and yeah. We're this much closer to being able to calibrate oscilloscopes now that I've got one of these. This is still a work in progress. This is the CG5011 with a very strange fault symptom that I'm trying to resolve. I'm actually waiting on some parts to build some extender cable so I can work on that. while it's in this. This guy's a lot easier to work on because it's only a one, you know, it's only a one slot wide, so you can work on it easily from both sides. Not the case with that guy, but once I have both these up and running and calibrated, be able to start calibrating scopes, which is the reason I got them for. But yeah, alright, that's it for this one. I'll catch you guys next time, and thanks for watching.